This is Tatiana from Tatiana Math Resources, and we're looking at the topic trigonometry using trig ratio, Pythagoras theorem with right angle triangles. One of the questions had a little surprise. We had to use the cosine rule. Our objectives are: one, we need to know how and when to use the trigonometric ratio, and we need to know these ratios. Two, know how and when to use the Pythagoras theorem method and also know the formula. And then three, we're going to demonstrate using some examples, two examples from CXC past papers using trig ratio, Pythagoras theorem, and one of the questions had a little slight, you had to use a cosine rule, which makes it all the more interesting. Let's get right into it. But before we get right into it, let's remember the Pythagoras theorem rule. Here we have our right angle triangle, the right angle, and the side of the triangle that is opposite the right angle is known as our beautiful hypotenuse. And the formula for the Pythagoras theorem is the hypotenuse squared to the second power is equals to the other two sides, a squared plus b squared. So just remember that formula. And let's remind ourselves about the trigonometry ratio or trig ratio. Again, right angle triangle. And we also need to know how to label a right angle triangle. So we have the right angle, and the easiest one is that side of the triangle that is opposite the right angle is called the hypotenuse. Here we have our angle theta or angle theta. Right next to it is adjacent, and then the last side is the opposite. So if you know for sure the hypotenuse and the adjacent, there are only three sides, so the third side is the opposite. And the rule is, well, let me write out the little code. It is OHSAHCOAT. Now this is pronounced various ways, but I look at it as being OHSAHCOAT. So the sine rule states sine theta is opposite over the hypotenuse. The cosine rule states cos theta is equals to adjacent over hypotenuse, and tan theta is equal to the opposite over the adjacent. So let's remember that because we're going to be using it, or we need to know when to use this in the questions that we're going to look at after this slide. Here we have the January 2009 question 3B. We have the triangle and it's labeled nicely for us here, and we're asked to calculate in meters the length MK. So we're talking about here, this line here, MK. Good. We recognize that the angle at M or LMK is 90 degrees. That means that KMN is also 90 degrees because it's on a straight line. Now, once we have right angle triangles, the only two rules that we can use are one, the trig ratio, and we discussed that ratio in the previous slide, or the Pythagoras theorem, which was also discussed in the previous slide. There is also a video that I have, and I will put that link in the description below for this video. Okay, so MK. So we use Pythagoras theorem when you have the length of two sides of a triangle. Keep in mind that a triangle has 1, 2, 3 sides. So once you have the length of two sides, you would use Pythagoras theorem. Now if we take out this triangle MKN, we're going to recognize, just draw a sketch of it here. I'm going to be too perfect. Remember, it's a sketch. So MN, here is 30. Here is 10 meters. This is K, that's M. We recognize we have an angle at N and we have a length. So that means we have to use the trig ratio. First step, label the triangle. So here is going to be our right angle. That means KN is our hypotenuse. MN, right next to the angle 30 degrees, will be our adjacent. And on the opposite, KM would be our opposite. It's opposite to the angle 30 degrees. Now we were given the hypotenuse and we're trying to find the opposite. So opposite and hypotenuse, that is our sine rule. Okay, let me just write that here. So sine theta is opposite over hypotenuse. Cos theta is adjacent over hypotenuse. And tan theta is opposite over adjacent. Okay, so we're going to use the sine rule because we have the opposite and the hypotenuse. So let's write that down. So sine theta, opposite over hypotenuse. Our angle is 30 degrees. Our opposite, that's what we're trying to find, MK over 10. So we're going to cross multiply. This is over 1. And we're going to get 10 sine 30 degrees is equals to MK. Plug that into your calculator and let's see what we get. That is going to give me 5 meters. So the answer here, the length 5 meters. Okay, so we're at part 2. It says here, calculate in meters the length of JK. So we had worked out that MK in part 1, 5 meters. And now we're being asked to find JK, which is here. Let me use red. JK right here. Now you would notice that is the triangle JLM, and it's a right angle triangle. We have two sides of the triangle, LM and JL or LJ. So once we're dealing with a right angle triangle, keeping in mind that here is also a right angle, there are only two rules we can use, and that is the trig ratio, and the next one is called the Pythagoras theorem. Okay, so if we take that triangle out, you notice the Pythagoras theorem rule here. So we took the triangle here, JLM, and we have it here. So we're going to use the Pythagoras theorem rule. So it's the hypotenuse squared equals to a squared plus b squared. Now we need to label this triangle. So we know, and when we say label, is to identify which side is the hypotenuse. And the side as the hypotenuse is the side that is opposite to the right angle. And that is JL, 13. So I'm going to write my 13 there. And it has to be squared. Is equals to, now we have L, and that was LM. And it's 5 meters. So I can make that A. So I put 5 squared plus b squared. So obviously my b squared is going to be this length. Okay, keeping in mind part of it is km, but we will deal with that after we find jk. So I want to find b. So what I'll have to do is 13 squared is 169, and I'm going to move this 5 squared over the equal sign, and it's going to become minus 25. So I've squared it, b squared. If I take 25 from 169, I'm going to get 144, b squared. We want b though, so we square root both sides, and we're going to get b is equals to 12. So from here, j m is 12 meters. But remember, we found km. So down here, we're going to say jk will be equals to 12 meters minus the 5 meters, which is 7 meters. And that is the answer, 7 meters. Here we have the 2010 May-June question, and here we have our diagram. Now we're being asked to calculate, given your answer correct to 3 significant figures, the height ft of the flag pole. So they're talking about here ft. Okay, so if we take that triangle out, this is how it's going to look on this side here. So we have everything from the diagram here. Now we're being asked to find ft. So here is f. Okay, so we're dealing with a right angle triangle, and the only two rules we can use is the trig ratio and Pythagoras theorem. Now we use a trig ratio when we have an angle and a length. So we're going to be using number 1. Next step, we have to label the right angle triangle. So the side of the triangle that is opposite to the 90-degree is known as the hypotenuse. The side of the triangle that's closest to the angle is known as the adjacent, and right on the opposite is ft. Now we have the adjacent, and we are trying to find the opposite. Now which trig ratio does that represent? Let me write them down here quickly, and it is sine, okay, sine theta is opposite over hypotenuse, cos theta is adjacent over the hypotenuse, and tan theta is opposite over adjacent. And that comes from this rule here. I'm going to write it up here. OHS AHC OAT. Okay, OSA quote. So we recognize that we're taking the opposite and the adjacent, so that is tan. Okay, so we're going to write tan theta. I always like to write it out first, is the opposite over the adjacent. So tan will be the angle 55 equals to, we don't know the opposite, which is the flagpole ft, over 6. That is over 1. So we're going to get 6 tan 55 equals to ft. Plug that into your calculator, and ft is equals to, now I got out 8.568888804. Keep in mind that our answer has to be correct to 3 significant figures. So I'm going to write out everything I got. 8.568 4/8. Okay, I'm gonna write anything yet. This is what I have on my calculator. But to get it to 3 sig figs, we're gonna count, and that is 1 significant figure, 2, 3. Now the number after I count 1, 2, 3. So I'm putting my line the wrong place. So then I'm gonna come here. Now I'm gonna check this number. Is it 5 or more? Round up. So my answer is 8.57 meters. 3 numbers, 3 significant figures, 8.57. So because it's 8, it is 5 or more, so I have to round up. So this 6 is going to become a 7. All right, and that's the answer. All right, so we're continuing with the May, June 2010. So we're looking at part 2, and it asks that we calculate, given our answer again to 3 sig figs, the length EG. Okay, EG. Now we're using this triangle inside. Notice the first thing I notice is that it is not a right angle triangle. Okay, now here it is called side angle side. In other words, side angle side. That is the cosine rule. You want to find here. What is this? Okay, so the cosine rule states c squared equals to a squared plus b squared minus 2ab cos c. So the length, which is this, and the angle. So we're going to write it out. So we're going to get c squared would be EG. All right. So EG squared is equals to, and we could use any of the two, doesn't matter, 6 squared plus 8 squared. So I could have said 8 squared plus 6 squared. 2 times 6 times 8 times the cos 120. Okay, so you notice these two are opposite to each other. So we're trying to find EG, and EG is opposite to the angle 120. Hence, EG squared matches the cos 120. Good, so let's continue. So EG squared is equals to 36 plus 64 minus 2 times 6 times 8. That is 96 times cos 120 degrees. So EG squared is equals to, that's a 0, 6 and 3 is 9, and 1 is 10. 100 minus 96 cos 120. Okay, so we're going to plug that into the calculator. Well, let's work out the EG squared 100 minus whatever this answer is here. Let's plug that into the calculator. 96 times cos 120. All right, I got a negative 48. So the 2 minus signs there is going to give me a plus. Okay, so I'm going to get EG squared is equals to 148. And we want to find EG, but it's squared, so we're going to square root both sides. And when we do that, we get EG is equals to the square root of 148. Remember, this was squared, so we could square that too. So EG is equals, what is the square root of 148? Keeping in mind that our answer has to be given to 3 sig figs. All right, so my answer I got out was 2.16552. I'm going to stop there. So we want 3 sig figs. So let's count. 1, 2, 3. Draw our line here. Check this number. It is 5 or more. Round up. Okay, so EG will be equals to 12.2 meters. And that is the final answer. Here we're asked to find the angle of elevation of T from E. So that's T here from E. So we're talking about this angle here. Okay, so we take that triangle out. It's going to look like this. And we recognize that it's a right angle triangle. The only two rules we can, or two formulas we can use is the trig ratio and Pythagoras theorem. Now, it can't be Pythagoras theorem because we're trying to find an angle. Okay, here at E. So it's a trig ratio. And those are sine theta is opposite over the hypotenuse. Cos theta is adjacent over the hypotenuse. And tan theta is opposite over the adjacent. So we have to label our triangle. So this is our hypotenuse. This is the angle. So that's opposite. And right next to it is our adjacent. So we are using what was given, which would be our opposite and our adjacent. So that would be tan. So here we go. Let's fill in what we know, which is we're looking for the angle tan, and the opposite is 8.57 over 8. So it would be tan inverse 8.57 over 8, and whatever that angle is. Okay, that is tan inverse of 1.07125. Plug that in. We're going to get 46.970. So we need to give the answer to 3 sig figs. So we're going to draw a line 1, 2, 3. So answer, or let's put the answer here. So we're going to get 46.9, but the 7, remember the rule, if it is 5 or more, round up. So that 1 is going to go across to the 9. That's going to become 10, and then it's going to go to the 6. So we're going to get 47.0 meters as our answer. And that's the final answer. This is Tatiana from Tatiana Math Resources, and we looked at trigonometry using the trig ratio and the Pythagoras theorem with right angle triangle, but in this case we had also a cosine rule. Okay, don't forget to like, subscribe, share, leave a comment. Stay tuned for more.